Hey guys, it's been a while. Been sick with the flu for a couple weeks, but as promised, I decided to make this video about Talking Tiki. Not exactly how I built it step by step, but what I want to do is I want to give back to the community and show you how to, basically, if we look at the inner guts of this, how to go and have a programmable robot that you can go program in movements and have it play it back to you, because that's basically what this is. It's 1, 2, 3, 4, 5, 6 servos, each one individually programmed, just repeating itself back what I programmed. So if I can show you how I did that, you could take this and you could make a tiki totem. You could go make an Igor, the other one I made. You could make your own animatronic that goes and repeats movements that you program, which I think is pretty cool. And I think it's a better way of doing things than me just saying, here, just duplicate this. Let's learn something new and how I go about doing it. One thing I will mention is I'm not a computer programmer. I'm a mechanical engineer by trade, so my code probably isn't as efficient as it could be. It works. The way I do it may not be the best way to do it, but it's my way of doing it, and I know it works well. I'll explain my reasoning behind it, and you guys can decide if you want to do it or not. If you have questions, comment below, and I'll try to answer them the best I can, and I'll also include the parts list for making this smaller version of this programmable robot. So we're going to break this down into 2 videos since it's going to take a while. Video 1 is going to be assembling the electronics, and video 2 is going to be going into the basic programming of how it works. And then once you combine the two, you should be able to create a puppetable robot that, in this case, I'm going to have it have an animatronic eyeball as my example. But whatever you want to hook servos to, it'll make it a robot that you can program. So we'll do 2 different videos. We'll start by assembling the parts in this one, and then hopefully in a couple weeks I'll do the coding and programming for the other one. The hope is that when it's done, I'm going to take this to MRF, Midwest Rep Festival, have it out on the table here at my booth, and people can come by and program it and play it back and get an idea of how one of these works without me having to open this up and pull all the wires out and whatnot. You'll get a good idea of how it works. Okay, so let's go through some of the parts you'll need. These are the main parts to build it. We may need things like wire and things like that. I'm not going to go through all that. I'll just start using it. You'll see that you'll need it. I encourage you to watch the entire video first to make sure that you get all the parts you need, because things like wire and solder, I assume that you have available to you. But here are the main components that you're going to need to build this this computer system. So this system is not the movement part, it's just the computer storage device and servo control. So we'll need servos and all that eventually, which I'll go through. But first, let's go through what the computer's brain is going to need. First of all, I recommend getting one of these, which is a terminal block for a Adafruit Feather. It's nice for tying in wires temporarily instead of soldering them in permanently. I'm going to use it for my input controls. They come pre-assembled, or you can solder them yourself. They're not too hard. Pick one of these up. It's nice to have. 2 sets of stacking headers. Okay. The brain of the system, the Adafruit 32U4. You're going to need one of those. I just get the basic proto one. You don't need any extra features on there just to get things to record. So just a 32U4 feather. The servo wing, feather servo wing, which controls 8 servos at once. So pick one of those up from the Adafruit store. Right-angled headers. I prefer them, so pick up a set of right-angled headers. You can pick them up with the servo shield. It'll ask you if you want a set of angled headers with it. Just say yes. It's like $1, $1.95, something like that. A female DC barrel jack adapter. Of course, got to power it, so a 5-volt power supply with a 2.1 millimeter barrel jack on the end. This will power the servos and will power our 32U4 card at the same time. Place where it stores all the movements and remembers everything. This is the I2C FRAM chip, 32 kilobytes, I believe. I use a bunch of these for storing data. So I think Igor uses like 7 of them. but for just what we're doing, you only really need one. So pick one of those up from the Adafruit store. A good soldering iron and some solder. and we will be using some wire as well. I believe I'm using 24 gauge wire, but anything around there should work. We're not doing anything too high current or anything you have to worry about. So those are the parts that you're going to need to start doing this. So let's get down to business and start assembling this project. Okay, so the order of operations here is we're going to have the terminal board, then we're going to have the 32U4 on top of that terminal board, and then on top of that we're going to have the servo wing on top. So we need to set up the headers to get that to work. So let's start at the beginning. I'll assume you got the pre-assembled terminal wing, so we won't worry about that. Okay, so what you normally do is you take your 32U4 and they tell you go in here, take your male headers, which is what comes with the 32U4, plug them into your female headers so they look something, let's see, there we go, like that. Take your card and line it up with the holes like that, and this makes its own holder where you can solder each one of these. Unfortunately, because we need to stack another wing on top of this, we can't use the male stacking headers, so this won't work. The problem is with the female stacking headers is they get inserted from the top of the 32U4. So putting these in here, putting these in here. So the stacking headers sit on top. If you go and try to press these into the terminal wing, you actually you need to be able to solder on the bottom side. So sticking them in here isn't going to work. One option is you can put the male headers, if you got male headers, you can stick them inside the terminal wing, turn this upside down to get everything to line up. But I'm going to show you a different way that I do, that I've done many times and made many screw-ups to begin with, and learned that this is probably a better way to do it. So let's try that. So what we're trying to do here is make sure that these terminals, the female stacking headers, are perfectly perpendicular to this card surface here. Hopefully you can see that. When you solder them, if they're angled like that, you can't stack anything on top. You want to make sure they're square. So what I used to do, which was a dumb mistake, is I would go flip this thing over on the table, solder all the different terminals, turn it over and say, that's not square, and try to unsolder everything and have a really hard time with it. So the trick is with the stacking headers, solder one pin on each stacking header, check for squareness, desolder if you need to, and then go solder everything. So let's go try that. So just solder one pin, hold it on there, let it get hot, solder flow, one, and do one on the other one, let it flow, pull it off. Okay, so I soldered one pin on each side. Let's take a look. And you can tell that this one, I think it's more light here. This one isn't square. In fact, neither of them are quite square, getting close. So the way around that is what we're going to do is the one that we just soldered, the pin we just soldered, we're going to go heat it up with a soldering gun, and while it's hot, move the header back and forth until you feel it that it's perpendicular to the circuit board. Okay, so let's give that a shot. So now we can go in there, being very careful. It is hot. Heat it up until it's flowing. There we go. And you'll feel when it's square. Let it go. Good. And do the other one. Heat it up. Now you can move it. Hold it till it's square. And now you should be able to see both of those are now perpendicular to the board. One mistake I used to make would be I'd solder them. If you solder them all, you'll never get them unsoldered or desoldered at the same time to get it squared back up. Solder one pin on each, get it squared up, and then once you know it's square, then go back and solder each one of the pin locations along here. So I'm gonna go solder each one of those and we'll come back and see what to do next. Okay, so now you go back and check your pins and make sure that the solder joints are all good. You don't have any cold solder joints or you miss anywhere. Looks pretty good. All right, this looks like a good solder job. And now for the test of how square these pins are, we take our terminal board, take our 32U4, it'll only go in one direction, stick it on top of the headers. And if I did it right, pops together just like that. Okay, so we have the 32U4 installed. Let's put together the servo wing and stack that on top. Okay guys, I misspoke earlier. I said you needed 2 stacking headers. Technically you don't. You can use them, they're great. However, since we're gonna just be stacking the servo wing shield on top of the 32U4, you can use the male headers that come with the 32U4. So let's do that, but you could use the female ones if you had them. There's no big deal. You can just change the order in which you stack them. So what you're gonna do is put the male headers into the top here of the 32U4. Then we're gonna take the servo wing shield. It will only go on one direction. And just place that on top. Line up the pins, there we go. So now it's sitting, there we go. Sitting on top, right there. What we're gonna do is use this as a holder, use the soldering iron and solder all the pins on both sides so that they're soldered to the servo board. So let's do that. So now that we're done here, we've soldered all the joints on both sides. Now we have this space here that we put this is the power to the servo shield, which they send you this lovely terminal block. So we're going to put that in there, and what we're gonna have to do is pull this board off and solder the back side of those 2 wires. I'll come back after we get that done. So now we have the terminal block soldered on. Okay, give a good dab of solder because that's a little bit of a load-bearing part sometimes, so make sure that's soldered on real well. Now you'll notice that there are holes here for all your servos. What we're going to do is take these right-angled headers and put them into the board. Now it's very important on orientation. I've screwed this up before. They do not go in this way with all the same length sides down. They go in, you'd think it would because you got the plastic sitting there. So if you go put this in, I mean, it looks good like that, but you can't, since the leads here are different lengths, you can't plug in the servo plug very well, it'll fall off. So the way that you're supposed to do it is turn the side with the short lengths, put those in, okay, and solder those like that, and then you've got nice equal lengths to plug in your servos to. So we need to turn this board over. We're gonna solder all those joints down there. I would use the same rules I did before, solder one joint, make sure things are squared up. If they're not square, heat up that one joint until things are square, and then go back and solder all the joints. So I'm gonna go do that now. Okay, so we've got all the solder joints soldered here, all the solder joints soldered here. This board is ready to go. Okay, this is the I2C frame board. There's a lot of pins on here, but we're not going to use them all for this project. VCC is your 5-volt pin. Ground goes to ground. WP is write protect. We're not going to use that here. SCL is clock. SDA is data. We're going to use both of those. Clock and data are required to write and read to this chip. And A2, A1, A0, you pull those, I can't remember if it's low or high. I think it's, well, I'll look it up. But point being is if you pull these low or high, you can set different registers for the board. So say you have 7 or 8 of these on the same I2C bus, you can call up a different address and write to this chip or another chip or another chip if you have each of these boards set to a different pin. So without setting them to
without setting any of these pins. I believe the initial address is 50 hex. So we're going to leave that not set. But if you have multiple boards, you can pull these pins high or low depending on what it says on the Adafruit Learning Guide, and put in multiple chips if you need them. So we're going to wire VCC, ground, SCL, and SDA to the 32U4 microprocessor. So let's solder this board up.
Okay, I've tinned all the wires on the end, so now they're solid instead of braided. So let's go, and we're going to take I usually do red wire for 5 volts. And we're just going to stick that through the front, the chip, through VCC, flip it over, and put it in the vise, and let's solder it down. Probably good to mention too, on the back here it says the board uses 2.7 to 5.5 volt logic. So the 32U4 is a 3.3 volt board, so you can power it with 3.3 volts up to 5 volts, and it's perfectly fine. All right, the next one over is ground. So I usually use black for ground to stay consistent. Flip it over. Solder her down. And make sure that you're not shorting out the wires between there. You want to make sure that there's no solder jumping between the 5 volt and the ground. All right, so then we need SDA and SCL. You can pick whatever color you want. So I'll do LCL as purple, and we'll do SDA as white. Flip it over, put it in the vise. Go. And solder it down. Okay. You can use your flush cutters to cut the ends off so that the back of the board doesn't have a lot of excess wire sticking out. And I'll give you a close-up look of what that looks like here in a second.
And there you go. So you have 5 volts or 3.3 volts, ground, SCL, and SDA. SDA is white, SCL is purple. We're ready to hook this up to the screw shield. Let's do that. One thing about cable management, guys, since the 5 volts and ground on this breakout board are right next to each other, I wrap those wires together, I twist them together, and the SDA and SCL, the clock and data lines, they are right next to each other, so I wrap those 2 wires together. You don't have to, but when you get more and more wires, they tend to get tangled, so planning ahead and wrapping wires together to make things less messy is a good practice to get into. So let's hook this up. So let's first go with the red wire, which is our VCC. I said you could use up from 2.7 volts to 5.5, so we can go to the breakout board here, and both these top ones are 3.3 volts. So let's use the ones right next to each other here. So let's put this one into 3.3 volts. Take your little screwdriver, screw it down. Always check to make sure that your connection's good. Next we have ground. That goes into the one below it, GND. Make sure it's tight. Okay. We go down here, look for SCL is purple. Grab the purple wire, put that into SCL here. Tighten that down. And triple check. And SDA is white. Put that into SDA. And guys, you could solder this directly onto the board if you wanted to. I just, for purposes of this demonstration, I like to be able to take the connections apart. So there's our FRAM chip on our board. So now we have servo shield, we have the 32U4, we have the breakout board, and we have the FRAM chip. So this is our memory. So now I think all we need to do is hook up the power for the servo shield. So let's do that. Okay, to save time, I went and cut black and red wires, and I've already tinned the ends. So we need to hook it up to our power supply. So here's our power supply. Notice it's marked with plus minus to stay consistent. Plus 5 volts is going to be red, so we'll stick that in. And black, go to minus. And grab your screwdriver. Turn it down. Make sure they're on tight. Also, cable management again, guys. So things don't get caught up. I recommend twisting them together just a little bit. You go look here. You've got your power for your servo shield marked conveniently plus and minus. So again, plus being red, minus being black. So take the red wire, put it into the plus side. Screw it down. Black wire into black side. Go. All right, check the wiring, make sure it's tight. And there's our power for our servo shield. All right, guys, the last little bit here is we have the power here to our servo shield from our 2.1 millimeter DC barrel jack, but also the microprocessor needs to be powered. Now, normally you could plug in to here with a USB cable, micro USB cable, and everything would be hunky-dory, but then you got to have 2 plugs in the wall, or one plugged into a computer and this one plugged into the wall. So one way around that is you'll notice that one of these wires here is labeled USB and one is ground. So what that's saying is if you were to power it through here, the microprocessor, you could pull the 5-volt power that this is supplying off this line. It also works in reverse. If you apply 5 volts to this USB line, you don't have to have anything hooked up here, and it powers the micro. So what I did was you take a second set of wires, so ground to negative, red to positive. 5 volts goes into USB, ground goes into ground, and now our system is completely powered up. So that is how you create your controller system for Arduino robotics. So in the next step, we'll talk about the input devices and how to hook them.
I think we're going to call it good here for episode 1. It's running a bit long, so we've got the electronics, we've got the 32U4, we've got the servo shield, we've got the frame chip all together. We've basically built the brains of the system. In the next video, I'm going to show you a little bit about the inputs. So joysticks, capturing eye blinks and mouth movements and all kinds of fun stuff. We'll talk about setting that up in the next one, and maybe a little bit about eyeball mechanisms and how I got mine to work. And in the final video, we'll go through the code and do a basic code generation that stores the movements and then plays them back to you. So stay tuned to part 2 and part 3 where we do that, hopefully in the next week or two. And see you on the next one. Thanks.